All right, welcome back to part two. Hopefully you and your DFF had some time to look over those three examples to see if you guys had any questions. So we're going to go ahead and do in 3 or 4 more examples and see how we're doing from there. So next one, sorry, that's example number 4, is 2x plus y equals 7 and 3x plus 3y equals 6. Hopefully some of you are starting to ask the question, well, wait a minute, what do we do? Because we're supposed to have a variable isolated. Well, if you don't have a variable isolated, you look for a coefficient of 1 or negative 1. Remember that a coefficient is the number in front of a variable. So if we look at this, which equation has the coefficient of 1? Well, the first one does, and it's y. So the very first step we have to do is isolate this y. Get y to equal negative 2x plus 7. Okay? And now I'm working with these two equations here. Okay? Obviously make sure that you solve the variable correctly, otherwise the entire problem won't be correct. So now we go back to what we were doing. We have a variable that's isolated. We're going to isolate it into the equation above it. This one equals negative 2x plus 7, so when I substitute in for y, it should also look like negative 2x plus 7. So 3x plus 3, don't forget the 3 in front, in parentheses, negative 2x plus 7 equals 6. Notice that how this matches. Okay, so I replaced this y for the y below it, and the y below it equaled negative 2x plus 7. Now I solve it like a typical equation. I get negative 3x to equal negative 15, so x equals 5. Now remember that in order for you to have a solution to a system, it needs to be an ordered pair, and there's 2 parts to the ordered pair. So we need to plug it back into one of the original equations. It doesn't matter which one you choose. I'm going to choose the first one just because it had a single y. So 2 times 5 plus y equals 7. Y equals negative 3. So my answer is 5, negative 3. And of course you should check it, so right below it, we use this equation to find the missing variable, so I'm going to choose one below it. So 3 times 5 is 3 times negative 3. It's 15 plus a negative 9. That does equal 6, so I did it correctly. Okay, so your answer is 5, negative 3. All right, just a couple more. Number 5, we have negative 2x plus 2y equals 4, and x minus 2y equals 10. Okay. Now, you don't have to look for the coefficient of 1 or negative 1, but what happens when you get a fraction? I know how much you all love doing fractions, so it's just nicer to look for the one that has a coefficient of 1 or negative 1, regardless if it's the x or the y. So notice that this is the equation that has a coefficient of 1 or negative 1. So I'm going to solve it. So I get x to equal 2y plus 10. And now here are the 2 equations that I'm working with. Okay. So I'm going to circle the x that I'll be replacing, highlight what I'm going to replace it with, and I get negative 2, and then in parentheses 2y plus 10 plus 2y equals 4. Remember that the whole point of substitution is to get down to one variable, which is what I just did here. Okay, I substituted in 2y plus 10 in for the other x so that I have an equation of one variable. So negative 4y minus 20 plus 2y equals 4. Okay. I get negative 2y to equal 24. And then I get y to equal negative 12. Okay. Make sure that you distribute the negative through to everything. All right, so let's plug this back in. X minus 2 times negative 12 equals 10. X plus 24 equals 10, so x equals negative 14. Let's make sure that works in the other equation. So negative 2 times negative 14 plus 2 times negative 12 has to equal 4. 28 minus 24 does equal 4. So negative 14, negative 12 is my answer. Okay. So once again, you have to isolate a variable. We isolated one from here to here. From here to here. And then we take what it equals, plug it back into the equation, solve for y, plug it back in for y, solve for x, and you get negative 14, negative 12. Okay. All right, last example we're going to do, example number 6. Okay. And once again, you're going to look for a variable that's isolated. We don't have one, so you're going to look for a coefficient of 1 or negative 1. And we have one right here. Okay. But the key thing here is notice that this coefficient is a negative 1. So I have to do a couple things in order to solve and isolate that variable. So I get y to equal 5x minus 4. So here's one equation I'm working with, and then here's the other. Okay. So remember, the first thing you do is isolate a variable. So now I have my two equations. I have y there, y there. Highlight it and highlight it. So we get 2x plus 3 times 5x minus 4 equals 5. 2x plus 15x, make sure you distribute through to everything. 17x equals 17 and x equals 1. Once again, it does not really matter which equation you plug it back into, so don't have to worry about the negative in front of the y. I'm going to use the bottom one. So 2 times 1 plus 3y equals 5. 3y equals 3, so y equals 1. And then, of course, you would check to make sure that 1, 1 is your answer. Okay, like I stated several times before, the nice thing about systems is that you can figure out what you did right or wrong by just taking the solution and plugging it back into the system. Okay? You guys have the rest of the time to work on the homework. Is the page in the book. Tomorrow, again, I won't be here, so you guys will be going over the homework and just spending another day on substitution so that hopefully you guys are good to go on it by the time I come back. Okay? All right. Have a good day. See you guys later.